The night sky has always carried secrets, but some of them whisper louder than others. This story begins with a silence so deep and so ancient that it seems to lean toward us from across the darkness, as if the universe itself is trying to speak. Astronomers often describe the cosmos as a vast, cold ocean of light, but every so often, hidden within that ocean, something appears, something that should not exist, something that pulls at the mind like a distant echo. Before the discovery was ever confirmed, before the numbers and simulations and late-night debates, there was only this: an impossible flicker buried in the cosmic background, a faint signal wrapped in mystery. Imagine the camera drifting through a slow river of interstellar dust, each particle catching the distant glow of stars born long before Earth ever turned solid. The silence is thick, almost heavy. Then suddenly the faintest shift, like a ripple across still water, catches our attention. A glimpse of something enormous, far beyond the reach of ordinary comprehension. This is where our journey begins, at the border between the known universe and the unimaginable. To understand the magnitude of what was found, you must first feel the scale of cosmic distance. Not as a number but as an experience. Light moves at 299 million meters per second, fast enough to circle Earth 7 times in one heartbeat. And yet, even traveling at that impossible speed, it can take billions of years just to cross the emptiness between ancient galaxies. When astronomers peer into the darkness, they aren't just looking far away, they're looking backward in time, into epochs when the universe was young and volatile. It is in this time-warped landscape that the anomaly first appeared, a strange and oversized structure glowing faintly from a period of cosmic infancy. At first, no one gave the signal more than a passing glance. Telescopes constantly collect oceans of data, much of it filled with noise, distortions, and false triggers. But the flicker persisted, appearing again when checked, refusing to vanish, refusing to blend into the background. It was as if the cosmos was gently clearing its throat, waiting to be heard. Some discoveries crash into existence with loud headlines and immediate certainty. Others arrive quietly, almost shyly, like shadows that grow sharper the longer you stare at them. This discovery belonged to the second category: subtle, persistent, and strangely unsettling. The world of astronomy is built on patterns. Galaxies tend to form at certain speeds, cluster at certain scales, and follow certain rules. These patterns are comforting in their consistency. They give scientists the illusion that the universe behaves in predictable ways. But every now and then, something appears that fractures that sense of order. This galaxy didn't just break the rules, it shattered them. It wasn't simply massive, it was impossibly massive, so large that it caused immediate cognitive recoil. Human minds, shaped by life on a small planet under a small sky, struggle to process anything beyond a few thousand light-years. Yet here was a structure stretching across distances so immense that the numbers felt almost hostile. As the flicker transformed into clearer data, the emotions in the observatories shifted, from curiosity to confusion, from confusion to a kind of awe-laced fear. Because hidden within that faint beam of ancient light was the suggestion that the early universe may have been capable of things far more dramatic, far more violent, far more unpredictable than anyone had dared imagine. It was like finding the footprints of a giant in a place where only dust and small stones should have existed. The first astronomers to analyze the signal described a strange sensation, as if the data were demanding to be taken seriously. The galaxy's brightness curve didn't match known early universe patterns. Its mass estimates kept climbing, each recalculation making the numbers more disturbing. And its age, its impossibly old age, told a story no model was prepared to explain. You can imagine them staring at their screens, the glow reflecting off their tired faces at 3 in the morning, realizing that they might be looking at something that defied every assumption they had learned. Cinematic imagery pulls us closer, a telescope dome slowly opening under a sky thick with stars, cold metal humming softly, gears rotating like ancient machinery responding to a cosmic summons. Inside, the scientists sit surrounded by a galaxy of data points, graphs, spectral lines, each one whispering the same impossible truth. Outside, the universe watches silently, indifferent yet magnificent, unaware of the chaos it is about to unleash in the world of human understanding. The deeper the astronomers looked, the more unsettling the picture became. This wasn't just a large galaxy. It was a titan, a colossus born far too early, too quickly, too smoothly. According to all existing theories, a structure like this should have taken billions of years to assemble. Yet here it was, shining from a time when the universe was still stumbling through its chaotic youth. It was like finding a skyscraper in the middle of a newborn city made of huts, an architectural impossibility that forced everyone to question whether the city itself had formed the way they thought it had. At this point, the mystery transformed from a curious anomaly into a cosmic crisis. If this galaxy was real, and all signs pointed to the fact that it was, then the universe had been hiding secrets about its earliest era. Perhaps gravity behaved differently then. Perhaps matter gathered in ways no simulation had ever predicted. Or perhaps something even stranger had happened, something beyond the boundaries of known physics. Whatever the answer, its implications were enormous and unsettling enough to make even seasoned astrophysicists feel small. The emotional contrast at this stage is palpable. Awe at the sheer beauty of the discovery, dread at the collapse of long-held assumptions, excitement at the doorway to a deeper truth. Humans often imagine the universe as a place of calm, serene stars drifting in silence. But discoveries like this reveal a different reality, a wild, furious cosmic engine capable of creating giants in the dark. The silent call of the impossible ends with a sense of unresolved tension. The galaxy has announced itself, but not its meaning. It sits at the edge of our understanding like a riddle carved into the night. And as the camera pulls back, drifting away from the glowing monstrosity and into the endless void, one question hangs in the air, quiet yet profoundly unsettling. If something this massive can exist so early in the universe, then what else is out there, still waiting to be found? The discovery did not begin with fireworks, announcements, or a sudden, dramatic revelation. Instead, it emerged from a single flicker, an almost accidental whisper in a sea of cosmic noise. Imagine a screen filled with static, the kind of visual snow that makes everything look chaotic and unreadable. Now imagine that, hidden inside that chaos, one pixel pulses differently. Not brighter. Not louder. Just different. That was all it took to start unraveling one of the greatest cosmic puzzles modern astronomy has ever faced. Deep inside a remote observatory, perched high above the cloud line where the air thins and the world grows quiet, the first signs of the anomaly slipped into the data streams. The telescope, a giant metal creature made of glass, gears and patient precision, had been sweeping across a region of sky rarely examined in detail. Its sensors were gathering light so ancient that each photon was older than Earth, older than the Sun, older than the continents and oceans and every life form that ever breathed. To humans, this light was a message from the past, faint and exhausted from its journey across billions of years. But even in its tired state, it carried secrets. The flicker came through as a faint curve, a slightly unusual bump in the frequency distribution. At first, it didn't look like anything special. Minor distortions happen all the time, dust interference, atmospheric fluctuations, instrument quirks. But this bump had a peculiar stability. It remained exactly the same when cross-checked across multiple exposures. It didn't vanish when the data was cleaned. It didn't flatten when recalibrated. If anything, the anomaly grew sharper, like a shadow sliding into focus. The astronomer reviewing the scans leaned closer to the monitor, narrowing their eyes slightly. The signature didn't match any known pattern for distant galaxies, nor any familiar artifact. It was as if the universe had placed a tiny marker, a quiet signal saying, "Look again. Look closer. Something is here." Over the next several hours, more data was pulled from storage, run through programs, and compared with earlier surveys. The flicker was subtle but persistent. It showed up at the same coordinates in multiple datasets, separated by years. The region was far from anything notable, a patch of sky so empty it barely earned a mention in star maps. That emptiness made the flicker even stranger. Why would something so massive, so luminous, so ancient hide in a region considered cosmically irrelevant? The night outside the observatory deepened. The wind slid across the mountaintop like a cold whisper. Inside, glowing monitors illuminated focused faces. The team began running more refined scans, using high-sensitivity filters to isolate the source. As the software rendered a clearer model, the anomaly's outline sharpened. It was faint, painfully faint, but unmistakably real. Imagine a spotlight shining from the end of time, but so heavily stretched by the expansion of the universe that its glow arrives distorted, like a voice slowed down across a great distance. That was the nature of the flicker. Ancient light, warped by billions of years, yet still determined to reach us. With each recalculation, the image became more distinct. Not enough to reveal the full shape, but enough to suggest something large, larger than expected, larger than logic allowed. A galaxy or something behaving like one but far too massive for its era. A quiet shiver moved through the room. The astronomers didn't yet understand what they were looking at, but instinctively they sensed its importance. The tone in the observatory shifted. Conversations slowed. The air seemed heavier. Curiosity mixed with a hint of unease. Humans have always reacted this way to the unknown, a primal pull, a mix of attraction and apprehension. Something deep inside us recognizes when we are brushing against the edge of understanding. As the team zoomed in further, they noticed something else. The surrounding area contained faint distortions consistent with gravitational lensing. The kind of bending you'd expect when something extremely heavy lies behind a foreground of cosmic dust. But the distortion was too strong, too pronounced for an early universe galaxy. It suggested a mass concentration far beyond reasonable prediction. By now, the astronomers had gathered additional data from partner observatories, checking if they too had recorded any anomalies at the same coordinates. Slowly, a pattern emerged. Not only had the flicker been captured before, but earlier teams had dismissed it as a calibration fault or minor interference. No one had dared consider that something monumental might be hiding in plain sight. Sometimes humanity's greatest obstacles aren't the mysteries of the cosmos, but our own assumptions. As the significance grew clearer, so did the emotional intensity. The observatory's quiet atmosphere turned electric. People moved faster, spoke faster, stayed awake longer. Coffee cups multiplied. Notes cluttered desks. The flicker had ignited something far more powerful than a data review. It had awakened hope, the dangerous kind of hope that only appears when a scientific discovery begins to feel like destiny. The cinematic imagery of this moment is striking. A close-up of shifting spectral lines, hands typing urgently, a distant thunderstorm flickering on the horizon, the telescope's massive body turning with slow precision, like a giant eye focusing on the faintest heartbeat in the void. Every component of this scene feels alive, waiting. The more the team analyzed the anomaly, the more it resisted classification. No standard model explained its brightness. No conventional timeline justified its mass. It was as if a piece of the universe had been misplaced, like a puzzle fragment that didn't belong in the box. And that was when the magnitude of the discovery began to sink in. The flicker was not noise. The flicker was not an error. The flicker was real. And it was coming from something bigger, older, and more unexpected than anything documented before. Scientists often dream of discoveries that challenge the foundations of their fields. They imagine the moment when they uncover something so extraordinary that it forces textbooks to be rewritten, theories to be rebuilt, and assumptions to be abandoned. This was one of those discoveries. And yet, instead of loud excitement, the reaction was almost reverent. Like standing inside a cathedral, hearing a distant note resonate through the walls. By sunrise, the data had crossed the threshold from anomaly to evidence. The flicker was now mapped across multiple wavelengths, traced through multiple angles, and verified across multiple systems. What began as a tiny signal buried in noise had become an undeniable presence. A galaxy so massive, so luminous, and so ancient that its very existence bent the boundaries of cosmic possibility. The astronomers stood at the beginning of a revelation they couldn't yet grasp. They had uncovered a structure that was not merely large, but impossibly large for its time. A structure that shouldn't have been able to form. A structure that defied the limits written into the cosmic blueprint. And as they stared at the early models, still crude and incomplete, one thought echoed through their minds with increasing clarity. If this galaxy exists, then everything we think we know about the early universe might be wrong. Before the flicker appeared on the screens of distant observatories, before astronomers' hearts raced at the thought of something colossal hiding in the depths of space, humanity had a narrative about the universe. It was a narrative of order, predictability, and incremental discovery, a cosmos that could be mapped, measured, and understood with patience and logic. From the earliest stargazers to modern astrophysicists, the story of the universe was a story of patterns. The spiraling dance of galaxies, the quiet rhythms of star formation, the invisible scaffolding of dark matter. We believed the cosmos operated within constraints that, though vast, were comprehensible, even if only in fragments. Cinematic imagery fills the mind. Picture a night sky over a silent desert, stars scattered like tiny diamonds across velvet black, each one following its invisible choreography. There's a sense of calm, a quiet that suggests stability. This was the universe as we had always imagined it, immense, yes, but obeying rules we could grasp. Galaxies formed from clouds of gas, condensed under gravity, spinning gently, growing slowly, colliding occasionally, but never suddenly appearing fully formed. Stars ignited over millions of years, planets coalesced around them, and in the vastness, human curiosity found a comfortable rhythm. Discovery, explanation, understanding. By the early 21st century, astronomers had mapped thousands of galaxies and probed billions of light-years into the cosmos. We had theories for everything: how galaxies clustered, how dark matter shaped cosmic architecture, how supernovae seeded the universe with the elements necessary for life. Our simulations produced intricate, beautiful models that mirrored the heavens, offering reassurance that the universe's behavior was, at least in principle, knowable. There was a sense of mastery, an intoxicating belief that we could predict, with increasing precision, the past, present, and even future of the cosmos. But mastery is always a fragile illusion, particularly when the cosmos is involved. The discovery of the flicker, the massive ancient galaxy lurking where it shouldn't, began to crack that illusion. To fully grasp why this was so disruptive, one must understand the expectations held by scientists. Galaxies were thought to grow gradually, a slow accumulation of matter over billions of years. Early galaxies, especially those existing a mere billion years after the Big Bang, were expected to be small, irregular, and chaotic, like adolescent cities under construction. They were not supposed to be titanic, smoothly structured, fully formed giants radiating light across billions of light-years. The contrast is cinematic in itself. On one hand, the calm, predictable universe of theory and simulation. On the other, the screaming, impossible reality emerging from the faint flicker of light. The tension is immediate, visceral. Human minds, evolved to navigate forests and rivers, struggle to comprehend a galaxy that exceeds imagination, that accumulates mass far faster than any known physical laws allow. It is one thing to see a storm on the horizon. It is another to realize the storm has been building for billions of years and spans a region of space beyond comprehension. To further understand the tension, consider the role of dark matter in cosmic expansion. Dark matter, invisible yet gravitationally potent, was thought to dictate the formation and growth of galaxies. It acted as the unseen architect, guiding ordinary matter into the structures we could observe. Expansion, propelled by the mysterious dark energy, stretched space itself, making distant objects recede and stretching light into wavelengths that require careful observation. These processes were thought to be well understood. Models could predict the number, size, and distribution of early galaxies with astonishing accuracy, until the anomaly appeared. This section of the story emphasizes the psychological impact on scientists. Imagine generations of study, theory, and simulation suddenly challenged by a single observation. Every line of code, every equation, every late-night debate suddenly seems provisional, incomplete, even naive. There is awe, certainly, but it is paired with a profound unease. Humans like to believe that the universe is knowable, that effort and intelligence can decode its rhythms. The flicker, the first hint of an impossibly massive galaxy, suggested that perhaps the universe was capable of surprises beyond the grasp of reason. Contrast deepens when we examine the observational perspective. Telescopes that once delivered familiar, orderly images now produce data that resists interpretation. Spectra that were expected to match models instead hint at masses, velocities, and structures that contradict decades of careful work. The more astronomers scrutinize the flicker, the more it feels like peering through a veil at a hidden theater of creation, a stage where familiar laws are bent, stretched, and redefined. It is as if the universe is holding a secret, one that will not be revealed easily, and which may force a reckoning with everything previously assumed. The narrative role of this section is crucial. It prepares the audience for the shock to come by establishing a baseline of what was known. The universe as humans understood it was a place of beauty, order, and logic. Its patterns were comforting, almost poetic, a framework within which human curiosity could safely roam. By contrasting this familiar picture with the evidence that something wildly anomalous exists, the script heightens tension and primes the viewer for the unfolding drama. It is not just a story of a distant galaxy, it is a story of the fragile certainty of knowledge, of the discomforting thrill of being proven wrong, and of the cosmic mystery that waits patiently for those who dare to look closer. Philosophical reflection threads through the science here. The calm, known universe provides a mirror for human assumptions. We organize, categorize, and predict because we must. Our understanding gives us comfort, a narrative that reassures us of our place in the cosmos. Yet the universe is under no obligation to conform to human expectations. This flicker, this impossible galaxy, is a reminder that scale and time in the cosmos are not merely large, they are alien. Even the most confident models are provisional when faced with evidence from billions of light-years away. Finally, the section closes with a sense of impending revelation. The audience is guided through the familiarity of established knowledge and then left suspended on the edge of contradiction. What was once predictable is now enigmatic. The universe that seemed so orderly is suddenly more complex, more violent, and more surprising than previously imagined. The flicker is not merely a curiosity, it is a harbinger of transformation, a signal that the story of the cosmos is far from complete, and that humanity's understanding, as vast as it may feel, is still only a small glimpse into the incomprehensible expanse of time, space, and possibility. In the quiet aftermath, one question lingers. If the universe we thought we understood can be upended by a single discovery, then what truths have we yet to encounter in the far reaches of space, hidden in light that has traveled billions of years just to reach our instruments in our minds? The first hints of the galaxy's true magnitude were subtle, almost imperceptible at first glance. But once the anomaly was confirmed, reality itself seemed to shift beneath the telescopes. The flicker that had once been a curiosity now demanded attention, and every subsequent observation revealed a universe more unyielding, more complex, and more astonishing than scientists had ever dared imagine. It was as if the cosmos, long considered a predictable expanse, had tilted on its axis, throwing centuries of assumptions into shadow. Imagine a massive telescope dome in the stillness of night, its giant metal eye swiveling with deliberate precision, scanning the heavens with patience that belied human urgency. Outside, the wind whispers over the mountaintop, stirring loose snow or dust across jagged rocks, a subtle reminder of the Earth's smallness. Inside, monitors glow with spectral lines and data points, a digital constellation reflecting the light that has traveled billions of years across space, carrying the secrets of a galaxy that should not exist. This is the threshold where reality bends, where understanding falters, and where the familiar universe transforms into something profoundly strange. At first, scientists tried to interpret the data using existing models. They adjusted for redshift, for cosmic expansion, for gravitational lensing, and for instrumental error. Each calculation was double-checked, triple-checked. But with every refinement, the anomaly persisted. It was real, and its properties were increasingly incomprehensible. Its mass was staggering, orders of magnitude greater than anything known from the early universe. Its structure was elegant, smooth, almost unnervingly so, defying the chaotic processes expected in young galaxies. The more the researchers examined it, the more the familiar rules of cosmic formation began to unravel. This section is a study in contrast, the calm precision of observation against the chaos of revelation, the logic of science against the wildness of nature. Observatories, usually temples of order and predictability, became arenas of tension. Researchers spoke in low, urgent tones, their conversations punctuated by the tapping of keyboards, the soft whirring of machinery, and the occasional exclamation of disbelief. Each new dataset brought both clarity and confusion, illuminating the galaxy's enormity while simultaneously shattering long-held expectations. To convey the scale, imagine the galaxy as a leviathan in the cosmic ocean, its mass curving spacetime itself, bending light from even more distant objects in ways that are both measurable and bewildering. Gravitational lensing reveals subtle arcs of distant galaxies, stretched and distorted by the unseen weight of this early colossus. And yet, despite these clues, its formation timeline remains impossible. According to prevailing cosmological models, the universe at that epoch was still young, its matter dispersed, its structures nascent. And yet here, in this single, faintly glowing object, was a behemoth that had assembled itself with shocking efficiency. Emotionally, the shift is profound. The initial excitement of discovery gives way to a creeping unease, a sense that something fundamental is being questioned. The human mind struggles to accommodate contradictions on a cosmic scale. For centuries, humanity has sought to map the heavens, to understand its rhythms, to predict its movements. Now, confronted with this anomaly, those maps feel fragile. The universe appears less like a known territory and more like a vast, uncharted wilderness, filled with giants lurking beyond the reach of reason. Cinematic imagery captures the duality of this moment. The soft glow of monitors illuminating anxious faces, the colossal telescope slowly pivoting under a sky streaked with starlight, and data visualizations that dance across screens like ghostly constellations. Every frame underscores the tension between the human desire for understanding and the relentless complexity of the cosmos. It is a universe that is at once beautiful and terrifying, elegant and chaotic, familiar and utterly alien. The galaxy's age adds another layer of astonishment. Photons from this object began their journey when the universe was less than 1 billion years old, a fraction of its current age. Light from this distant giant has traveled across space-time, stretched and reddened by expansion, yet it still carries information about a period when the cosmos was young and turbulent. That such a massive, ordered structure could exist at this time defies the predictive power of every current model. It is as though the universe had whispered a secret for eons, waiting until now for humanity to catch even the faintest echo. Contrast permeates every aspect of the discovery. The early universe, previously imagined as a chaotic, unstructured environment, suddenly contains entities of unimaginable scale and sophistication. Where scientists expected rough clumps of gas and star-forming regions, they found a smooth, massive galaxy already in place, already dominant. Where theoretical timelines predicted gradual accumulation, reality presents an almost instantaneous assembly. This juxtaposition magnifies both awe and uncertainty, compelling researchers to reconsider everything from the mechanics of galaxy formation to the very laws that govern cosmic evolution. Even the instruments themselves take on a cinematic quality in this narrative. Each telescope, each detector, each filter is portrayed not as a tool but as a conduit between human perception and the immense, indifferent universe. Through these mechanical eyes, photons that began their journey billions of years ago finally reach observers, each particle carrying the weight of time, energy, and unimaginable distance. The act of observation becomes almost spiritual, a communion with something vast and incomprehensible, yet tangible through measurement and analysis. This section also emphasizes the narrative tension inherent in science itself. Discovery is rarely straightforward. It is a process of trial and error, hypothesis and refutation, measurement and recalibration. The shift in reality under the telescope mirrors the emotional journey of the scientists. Initial curiosity, mounting confusion, profound astonishment, and the slow dawning recognition that the universe they believed they understood is more complex, more violent, and more miraculous than any human mind can fully grasp. Philosophically, the galaxy forces a confrontation with the limits of knowledge. Human understanding is structured, compartmentalized, and logical. It thrives on patterns and predictability. But the universe, as this discovery demonstrates, is capable of producing exceptions so extreme that they challenge the very foundations of comprehension. It is a reminder that for all our technology, mathematics, and insight, we remain observers on the periphery of a reality that is far larger, stranger, and more powerful than our imaginations allow. By the end of this section, the galaxy has moved from anomaly to icon, a symbol of the unknown, a challenge to every assumption, and a spark that ignites both scientific inquiry and existential reflection. The shift under the telescope is not just about data points or graphs. It is about the transformation of perception, the bending of expectation, and the profound realization that the universe is more inventive, more expansive, and more enigmatic than we had ever dared to believe. And as the camera drifts back from the glowing monitors, past the steel curves of the telescope, and into the inky expanse of night, one thought dominates. The cosmos is no longer a place of predictable order. It is a realm where reality itself can shift beneath our gaze, where impossibilities wait patiently for those brave enough to look, and where the line between the known and the unknowable is far thinner than anyone had imagined. The first time scientists attempted to quantify the mass of this newly discovered galaxy, the numbers seemed almost absurd. Each calculation, each model, each estimation pushed the limits of comprehension. It was not merely large by conventional standards, it was monumental, a colossus that stretched the imagination and defied every expectation for galaxies in the early universe. To say it was massive is almost to understate the reality. This was an entity so immense that traditional comparisons fail, a leviathan drifting through space and time, its very gravity bending not only light but the minds of those who attempted to measure it. Imagine standing on the edge of a cliff overlooking an endless ocean. Now, imagine being told that somewhere, far beyond the horizon, there exists a mountain so vast it dwarfs the continents you know. That is the scale we are trying to grasp. The mass of this galaxy cannot be simply measured in stars or solar systems. It must be imagined as a totality, an invisible weight pressing upon the fabric of space itself. Early estimates suggested that it contained hundreds of billions of solar masses, possibly more, packed into a structure that appeared unexpectedly organized for its age. Each photon arriving at Earth was a relic of that weight, a whisper of something impossibly heavy yet eerily elegant. The cinematic impact of such a mass is profound. Picture cosmic dust spiraling around dense cores of starlight, glowing clouds stretched thin by gravitational forces, and the subtle warping of surrounding space that betrays the presence of unseen mass. Gravitational lensing reveals arcs and distortions, elegant lines tracing the invisible influence of this giant. Observers, peering through sensitive instruments, can detect the bending of light from even more distant galaxies, a cosmic fingerprint of the Leviathan's existence. And yet, the human mind strains against these numbers. Billions, trillions, quadrillions of times the mass of our Sun, these are concepts nearly impossible to internalize, yet they define the reality of this entity. The galaxy's mass is not merely a statistic. It is a narrative in itself, telling a story of cosmic efficiency and early structure formation that existing theories cannot easily explain. Models of galaxy formation predict gradual accumulation, a slow gathering of matter under the influence of gravity over billions of years. But here is a structure that appears fully grown, mature, and dominant, existing in a universe less than a billion years old. It is a contradiction that forces scientists to reconsider the mechanics of formation, the speed of stellar evolution, and the behavior of dark matter and gas under extreme conditions. Emotionally, the realization of such mass is both awe-inspiring and unsettling. Awe comes from the grandeur, from understanding that the universe is capable of producing objects of such scale. It is the kind of beauty that evokes a deep, almost spiritual reverence, as if one has glimpsed a hidden architecture behind the visible cosmos. But there is also unease, a sense of cognitive dissonance, because the existence of this galaxy suggests that the early universe was far more capable, far more dynamic, and far stranger than previously thought. It challenges our assumptions, making even well-tested theories appear fragile in the face of empirical evidence. Contrast is key to understanding this galaxy's impact. In the early universe, most galaxies were small, chaotic, and irregular, still coalescing from the primordial gas and dust left after the Big Bang. They were adolescent, unpredictable, and incomplete. Then, juxtaposed against this familiar background, the newly discovered galaxy emerges as a titan, massive, smooth, ordered, and astonishingly mature. The emotional tension is immediate. Human comprehension struggles to reconcile the expected chaos with the observed order, the slow growth with the sudden grandeur. It is a visual and intellectual dissonance that heightens the sense of mystery and wonder. The scientific tools used to measure this mass are themselves remarkable. Spectroscopy reveals the velocity of stars and gas within the galaxy, allowing scientists to infer the gravitational forces at play. Observations across multiple wavelengths, infrared, optical, radio, construct a composite picture of the galaxy's structure, composition, and behavior. Each measurement reinforces the astonishing conclusion. This is not an anomaly in size alone, but in the sheer, almost impossible amount of matter concentrated in a single cosmic entity. Philosophically, the galaxy's mass provokes reflection on scale and perspective. Human beings are accustomed to thinking in terms of familiar units: mountains, oceans, continents. Yet the universe operates on a scale that dwarfs all terrestrial experience. This galaxy is not merely a collection of stars. It is a monument to the extremes of nature, a demonstration that the cosmos does not adhere to human expectations or limitations. Its mass invites both humility and wonder, forcing a confrontation with the vastness and complexity of existence itself. The narrative role of this section is to anchor the audience in the tangible enormity of the galaxy. Previous sections introduced mystery and anomaly, but here the story takes on physical weight. The mass becomes a character in its own right, a force that shapes the surrounding universe and exerts influence beyond the immediate region. Its gravity affects neighboring galaxies, bends the path of light, and serves as a cosmic reference point for understanding the structure of the early universe. By conveying scale through both scientific data and vivid cinematic imagery, the audience experiences the galaxy not merely as a concept but as an almost tangible presence. The tension continues to build as the implications of this mass are explored. If a galaxy this large can exist so early, what does it reveal about the behavior of matter, energy, and gravity in the young universe? Could other galaxies of similar or greater scale exist, waiting to be discovered? Are the existing models of cosmic evolution fundamentally incomplete? Each question underscores the drama inherent in discovery, highlighting the interplay between empirical evidence and theoretical expectation. Cinematic visualization heightens the sense of scale. Picture a dark, empty expanse of space suddenly illuminated by the glow of a titanic spiral, its arms stretching outward, dwarfing the faint pinpricks of smaller neighboring galaxies. Imagine gravitational waves rippling through surrounding space, invisible yet detectable in subtle distortions. Picture light from distant stars bending and stretching as it navigates the galaxy's immense gravitational field. Every frame is a reminder of human smallness, the grandeur of the cosmos, and the delicate balance between comprehension and mystery. Finally, the section emphasizes that mass is more than a physical measurement, it is an emotional and philosophical trigger. The discovery of a galaxy so massive reshapes not only scientific understanding but also human imagination. It invites viewers to confront the limits of perception, the fragility of assumptions, and the awe-inspiring capacity of the universe to surprise. The galaxy's mass is both a physical reality and a narrative device, a focal point around which the story of cosmic discovery revolves, compelling both scientists and audiences alike to grapple with the staggering implications of existence on a scale far beyond anything previously imagined. And as the gaze drifts from instruments to the night sky, one realization becomes unavoidable. This galaxy is not just a marvel, it is a challenge. A challenge to theory, to imagination, and to the very ways we measure and comprehend the universe. Its mass, colossal and undeniable, serves as a testament to the vast, untamed power of nature and the boundless mysteries that lie beyond the edge of human understanding. The light arriving from this massive galaxy is not just illumination. It is a message, a relic, a story written in photons that have traveled across the cosmos for billions of years. Each particle of light is a fragment of history, a signal that has endured the expansion of space, the influence of dark energy and the gravitational pull of countless unseen objects. Observing this light is like reading a letter from the infancy of the universe, a communication from a time when the cosmos itself was young, chaotic, and still forming its character. To peer into these ancient beams is to look back into a reality far different from the one we inhabit, a world in which the rules of formation, growth, and structure were already being rewritten. Cinematic imagery sets the stage, photons traveling across space, invisible and relentless, weaving through empty voids, dodging gravitational eddies, threading through the remnants of ancient supernovae. Each particle carries information about temperature, motion, chemical composition, and structure, encoded in wavelengths that stretch and distort as the universe expands. To the human eye, these signals are imperceptible, but through the lenses of highly sensitive telescopes and sophisticated detectors, they emerge as patterns, as curves on a graph, as faint images glowing against the darkness of observation screens. Each tiny signal hints at events that occurred billions of years before the Earth existed, before life had even begun to take its first tentative steps. Time in this context is both linear and malleable. The galaxy's light began its journey when the universe was less than 1 billion years old, a mere fraction of its current 13.8 billion year age. To receive this light now is to witness a cosmic relic, a preserved snapshot from an era where stars were young, galaxies turbulent, and matter still settling into the grand structures that define the universe today. Each observation is a portal into a distant past, a chance to study the processes that shaped not only this colossal galaxy but also the cosmos itself. Yet there is a tension inherent in this act. Light carries information, but it also deceives. Distance warps perception. Redshift stretches wavelengths, altering appearances. Even time, once thought absolute, becomes a variable, bending under the weight of cosmic expansion. Scientists describe the process of interpreting this ancient light as both exhilarating and humbling. It requires precision, patience, and imagination. Spectroscopic analysis reveals the chemical fingerprints of stars, the presence of dust, and the velocities of gases swirling within the galaxy. Infrared observations uncover regions shrouded in cosmic dust, regions where light has been delayed or obscured by intervening matter. Radio signals detect molecular clouds, the raw ingredients for star formation. Each layer of observation adds depth to the story, like peeling back pages of a book written in a language partially understood. And yet, with every answer, more questions emerge. How did this galaxy accumulate such mass so early? How did its stars form so rapidly? How did its structure maintain stability amid the turbulence of the young universe? The emotional resonance of this section comes from the interplay of scale, age, and mystery. There is awe in realizing that the light reaching us has traveled across billions of years and unimaginable distances, surviving the turbulence of space, immune to the passage of cosmic epochs. There is a quiet fear too, in the sense that humanity is only now beginning to witness these ancient events, standing on the edge of understanding and staring into a reality vastly older and stranger than our daily experience allows. The galaxy is both a time machine and a mirror, reflecting not only the early universe but also our limitations as observers bound by the constraints of perception and lifespan. Contrast deepens the engagement. The universe we observe today is orderly in ways the early universe was not. Galaxies have settled into familiar spirals or ellipses, stars burn steadily, clusters form predictable structures. But in the epoch revealed by this galaxy's light, everything is in flux. Matter is colliding, merging, igniting. Gravity sculpts chaos into structure with astonishing speed. This juxtaposition between the turbulent past and the seemingly serene present enhances emotional tension and narrative suspense. It emphasizes that the cosmos is not static, it is a story in motion, a narrative written over billions of years, with this massive galaxy as one of its earliest and most enigmatic chapters. The philosophical implications are profound. Light is more than a medium for observation. It is a messenger, a record, and a challenge. It confronts humanity with the question of perspective. Our existence, brief and localized, is dwarfed by the enormity of cosmic time. Yet, paradoxically, our ability to detect and interpret these photons demonstrates the remarkable ingenuity of human perception. We are simultaneously small and capable, fragile and persistent, finite yet able to glimpse eternity through the lens of science. Each photon from this galaxy is a reminder that knowledge is both possible and partial, that every discovery opens new vistas of inquiry while revealing the limits of comprehension. Cinematic description intensifies the impact. Imagine the telescope array sweeping across the night sky, its sensors capturing faint patterns that are then converted into color-coded maps, graphs, and images. The room is dim, filled with quiet intensity, as scientists analyze curves that represent billions of years of cosmic history. Outside, the night is silent, and the stars themselves seem to pulse faintly in acknowledgement, as if aware that their light carries secrets waiting to be decoded. The galaxy, distant yet insistent, radiates not only energy but mystery, an enduring enigma that challenges both theory and imagination. The narrative function of this section is to bridge empirical observation with conceptual wonder. Previous sections established the anomaly, its scale, and the initial shock it created. Here, the focus shifts to the medium through which the galaxy communicates: light and time. Understanding these elements allows the audience to grasp not only the physical properties of the galaxy but also the conceptual leap required to internalize its age and history. It emphasizes that discovery is not merely a matter of seeing but of interpreting, of translating the faint, ancient signals into human comprehension. Tension remains central. The more scientists decode the light, the more extraordinary the implications become. Each spectral line, each infrared glow, each gravitational lensing curve reinforces the reality of the galaxy's mass and maturity. And yet, these very observations create new puzzles. How could the universe, still so young, produce such a massive structure? What processes accelerated star formation, gas accumulation, and structural stability beyond current understanding? Every answer seems to hint at deeper mysteries, suggesting that the cosmos contains mechanisms and behaviors humanity has yet to comprehend. By the end of this section, the audience is positioned at the intersection of science and philosophy, awe and fear, observation and imagination. The galaxy's light is both proof and puzzle, a bridge to the early universe and a mirror reflecting the limits of human understanding. The photons arriving now are not simply old. They are ancient, carrying with them secrets of formation, evolution, and cosmic architecture. They remind us that time is a vast canvas, light a storyteller, and the universe itself an author whose narrative stretches far beyond human lifespan or comprehension. And as the gaze drifts from the glowing monitors to the expanse of the night sky, one realization becomes undeniable. Each particle of light is a bridge across billions of years, each photon a whisper from a universe that existed long before humans, and each observation a reminder that the cosmos is far stranger, older, and more magnificent than imagination alone can conceive. The secrets carried by this galaxy's light are only beginning to unfold, but already they reshape our understanding of time, matter, and the extraordinary depths of the universe. As the magnitude of the galaxy became undeniable, the calm, methodical world of astrophysics erupted into a storm of speculation, debate, and intense intellectual tension. The discovery was not merely a challenge to individual researchers. It was a challenge to the entire framework of cosmology. Theoretical models, painstakingly built over decades, suddenly seemed fragile, as if the universe had thrown a curveball that no equation or simulation could fully account for. Across observatories and research institutes, the air grew thick with the charged energy of confrontation. Hypotheses were drafted and discarded, simulations rerun, and debates held late into the night. What had once been a predictable cosmos now appeared wild, defiant, and uncontainable. Cinematic imagery brings this tension to life. Scientists huddle over glowing monitors in dimly lit rooms, fingers poised over keyboards, lines of code scrolling like cascading rivers of light. Outside, storms may lash distant landscapes, a visual echo of the turbulence within. Equations scrawled across white boards look both familiar and suddenly insufficient, symbols and numbers struggling to describe an entity that dwarfs conventional understanding. Every graph and model is a battleground, each interpretation a provisional victory that may be overturned by the next data set. In these rooms, the very act of thinking becomes a high-stakes challenge, a mental acrobatics routine performed at the edge of comprehension. At the heart of this intellectual storm lies the galaxy itself, massive and ancient, emitting photons that tell a story of formation, structure, and scale far beyond existing models. Traditional theories of galaxy formation suggest that massive structures accumulate slowly over billions of years, growing through the mergers of smaller systems and the gradual accretion of gas. Yet this galaxy, existing less than a billion years after the Big Bang, displays a maturity, mass, and organization that are unprecedented. The theoretical whiplash comes from the inability of current simulations to replicate such a structure within the known timeline of cosmic evolution. The clash of theories manifests in multiple directions. Some scientists propose that the galaxy's rapid growth could be explained by unusual dark matter concentrations, suggesting that unseen, massive halos accelerated the assembly of stars and gas. Others argue for extreme star formation efficiency, where clouds of primordial gas condensed and ignited at rates orders of magnitude faster than previously recorded. A few suggest even more radical ideas, proposing physics beyond the standard cosmological model, mechanisms that may involve modifications to gravitational theory, exotic particle interactions, or phenomena yet to be imagined. Each proposal carries its own risks, assumptions, and counterarguments, creating a dynamic intellectual ecosystem where certainty is fleeting, and every assertion is immediately tested and scrutinized. The emotional impact of this debate is palpable. Scientists are exhilarated by the challenge, but also frustrated, exhausted, and occasionally humbled. Here is a discovery that demands imagination, yet refuses simplification. The clash of ideas produces a kind of cognitive whiplash, alternating between exhilaration at the possibility of breakthrough and despair at the inadequacy of existing frameworks. It is a rare moment in science when empirical evidence forces a confrontation with the boundaries of understanding, where every accepted truth is suddenly provisional. Contrast intensifies the drama. On one side, decades of observation, theory, and computational modeling suggest a universe governed by predictable rules: hierarchical growth, steady accumulation, and gradual structural evolution. On the other side stands the galaxy, massive, mature, and ancient. A direct contradiction that challenges the assumptions underlying all current cosmological understanding. The tension is not merely academic, it is psychological, philosophical, and even existential. Humans have long derived comfort from the perception of a rational cosmos. Here, that comfort is stripped away, replaced by awe, fear, and the thrilling uncertainty of discovery. Cinematic description amplifies the sense of urgency and gravity. Picture a simulation lab filled with the hum of supercomputers, their processors rendering billions of particles to model galaxy formation. Researchers watch graphs spike, collapse, and reform in real time, models that once produced predictable outcomes now floundering under the weight of reality. In another room, discussions erupt over conference calls, voices tight with intensity, sometimes raised, sometimes hushed in disbelief. Each theory is tested, debated, and often rejected, the process reflecting both the rigor and the chaos inherent in the pursuit of truth at the edge of knowledge. The galaxy's mass and early formation timeline exacerbate this cognitive tension. It implies that processes in the early universe were capable of assembling structure at speeds far beyond expectations, suggesting a level of cosmic efficiency previously unimagined. If dark matter halos are more concentrated, star formation more explosive, or gravitational physics subtly different in the early universe, then the consequences extend beyond a single galaxy. Entire models of cosmic evolution may require re-evaluation, from the distribution of matter and energy to the formation of the first stars and galaxies. Each recalculation ripples through the theoretical framework, creating intellectual shockwaves akin to cosmic quakes. Philosophically, the clash of theories mirrors the human struggle to reconcile observation with expectation. It is a reminder that knowledge is provisional, that certainty is rare, and that even the most elegant models are vulnerable to contradiction. In this context, the galaxy becomes more than a physical entity. It is a symbol of the universe's ability to surprise, to evade human expectation, and to challenge the limits of imagination. Each proposed theory is an attempt to impose understanding on a reality that may ultimately remain partially unknowable, a dance between curiosity and humility that is as old as science itself. This section also emphasizes the narrative tension inherent in discovery. The audience witnesses the collision between evidence and expectation, the friction of ideas, and the emotional highs and lows that accompany the confrontation with the unknown. Each hypothesis, each debate, each failed simulation adds momentum to the story, increasing engagement by blending intellectual intrigue with dramatic tension. The clash is not simply scientific. It is cinematic, emotional, and deeply human. As the night stretches on, the galaxy remains an enigma, luminous and insistent. Its presence forces scientists to confront uncomfortable questions. How much of our understanding is provisional? How many hidden giants exist in the early universe, waiting to overturn established theory? And, most profoundly, what does it mean for human comprehension when the cosmos produces objects so massive, so ancient, and so organized that our best models cannot account for them? By the end of this section, the audience is drawn into the maelstrom of scientific thought, feeling the exhilaration and disorientation of the experts themselves. The clash of theories, the whiplash of expectation, and the unrelenting pressure of empirical evidence create a narrative tension that mirrors the cosmic drama unfolding billions of light-years away. It leaves viewers suspended between awe and anxiety, curiosity and fear, as the story of this impossible galaxy begins to expand beyond data, charts, and calculations into the realm of philosophical wonder and existential reflection. And as the camera pulls back from glowing monitors and animated simulations, across the observatory's steel frameworks, and into the silent expanse of the cosmos, one realization crystallizes. The universe is not merely a backdrop for human exploration. It is an active participant in the story of understanding, capable of defying expectations, rewriting rules, and forcing every mind that dares to observe it into a confrontation with the truly extraordinary. The galaxy does not exist in isolation. It is a relic, a monument from a universe still in its adolescence. To understand its existence, one must journey back to the primordial epochs, a time when the cosmos was young, violent, and unrecognizably different from the serene, structured universe we see today. Imagine a vast, swirling expanse of plasma and gas, thick with energy, punctuated by the birth cries of the first stars. Matter had only recently begun to coalesce under the influence of gravity, and the fabric of space itself was stretching rapidly, carrying nascent galaxies along with it. Every photon, every particle, every ripple of gravity tells a story from this time, a story that is preserved in the light arriving now from this massive ancient galaxy. Cinematic imagery illuminates this period. Primordial gas clouds swirl in violent turbulence, sparks of star formation ignite like lightning across the void, and gravity pulls and twists matter into chaotic filaments that will one day become the cosmic web. The young universe was not gentle or slow. It was energetic, relentless, and impatient. Collisions between proto-galaxies were common. Supernovae exploded with unrestrained fury, and black holes formed with alarming efficiency. Into this crucible, the colossal galaxy emerged, already massive, already ordered, already defying expectations. The contrast between the chaotic environment and the galaxy's apparent maturity amplifies the sense of mystery and awe. The term young universe may seem abstract, but its implications are staggering. Less than a billion years after the Big Bang, matter was still organizing itself, and the structures we now take for granted were embryonic. Galaxies were expected to be irregular, patchy, and turbulent, struggling to coalesce from diffuse clouds. Yet the light from this galaxy reveals a system that is smooth, concentrated, and disproportionately massive. Its stars appear fully formed, its gravitational influence significant, and its presence suggests a level of efficiency in cosmic construction that existing models cannot explain. This discord between expectation and observation is not simply scientific. It is existential, forcing us to rethink what is possible in the formative stages of reality itself. Scientists reconstruct these early epochs through observations across multiple wavelengths, each revealing a different facet of the universe's infancy. Infrared light penetrates dust clouds, revealing nascent stars forming in hidden nurseries. Radio waves detect cold molecular gas, the raw material for future stellar generations. X-rays hint at energetic processes, supermassive black holes and violent collisions. Each layer contributes to a multidimensional understanding of the environment in which this galaxy grew, and yet, the more we observe, the more enigmatic it becomes. Its very existence challenges the mechanisms we thought governed the early cosmos. Emotionally, this section emphasizes awe intertwined with disquiet. There is a kind of beauty in visualizing a universe so dynamic, so alive, even in its infancy. But that beauty is tempered by the stark realization that nature's processes can produce outcomes far beyond human expectation. The galaxy's emergence from this violent, unpredictable environment evokes a sense of wonder, but also a subtle unease. If the universe could construct such a titan so quickly, What other marvels or impossibilities lie hidden in the vast, uncharted regions of space? Contrast frames the narrative throughout. On one side, the young universe is chaotic, turbulent, and volatile. On the other, this galaxy appears almost serene, massive, and complete. This dichotomy highlights the tension between disorder and order, chance and inevitability, creating both intellectual fascination and emotional engagement. Observers are drawn into the drama not only of what the galaxy is, but of what it represents. A puzzle, a challenge, a whisper from a time that defies intuition and demands re-evaluation of cosmic timelines. The galaxy's early formation also raises fundamental questions about the underlying physics of the universe. How did matter accumulate so efficiently? How did stars ignite in such rapid succession without destabilizing the system? Were the rules of gravity or the behavior of dark matter subtly different in these early epochs? Could there be processes in the young universe that are completely unknown, mechanisms that operate on scales and efficiencies beyond anything currently conceived? Each question compounds the sense of mystery and heightens the narrative tension, transforming what could be a sterile scientific observation into a story of cosmic drama. Cinematic visualization enhances comprehension and emotional impact. Picture the galaxy forming amid swirling filaments of gas, gravity pulling clouds together into concentrated knots of light. Imagine explosions from the first supernovae illuminating the darkness, their energy shaping the surrounding matter, influencing the trajectory of future stars. Envision dark matter scaffolds, invisible yet guiding the collapse of gas into the nascent galaxy, providing a structure upon which the colossal mass could assemble. Every element of this scene reinforces both scale and wonder, emphasizing the extraordinary circumstances under which this galaxy came into existence. The narrative function of this section is pivotal. Previous sections explored the discovery, scale, and challenge to existing theory. Here, the focus shifts to context, the environmental conditions of the young universe that shaped, and were shaped by, this massive galaxy. Understanding its formation environment allows the audience to grasp the improbability of its existence, deepening both the scientific and emotional resonance of the story. The galaxy is no longer just a data point, it is a character emerging from a cosmic narrative, a witness to the turbulence and drama of the universe's earliest epochs. Philosophically, this section invites reflection on scale, time, and causality. Humanity perceives time linearly, events unfolding sequentially, processes requiring patience and duration. Yet the universe, particularly in its early stages, operates on scales and intensities far removed from human experience. This galaxy is evidence of efficiency and magnitude, a reminder that natural processes can exceed the imagination, that the universe may harbor mechanisms and efficiencies that remain invisible to our limited perception. It challenges the anthropocentric notion of proportionality, asking observers to reconsider the bounds of possibility in both space and time. The tension continues to build as the galaxy's existence reframes the narrative of cosmic history. If such a massive, structured entity could arise so early, then our understanding of hierarchical growth, star formation rates, and the accumulation of matter is incomplete. The very timeline of cosmic evolution may need revision, suggesting a universe more dynamic, more efficient, and more mysterious than models have previously accounted for. Every photon received is a clue, every measurement a reminder that reality has the capacity to surprise, challenge, and inspire. By the end of this section, the audience is fully immersed in the drama of the young universe. The galaxy emerges as both a product and a defiance of its environment, a titan formed amid chaos, its light carrying the echoes of a time when the cosmos was raw, energetic, and unpredictable. It is a bridge between past and present, observation and imagination, science and philosophy. The story of the galaxy is inseparable from the story of the universe itself, a narrative of creation, growth, and mystery that transcends human comprehension. And as the gaze drifts outward from screens and simulations, past observatory domes and mountain ridges, into the vast, silent expanse of the cosmos, one thought becomes unavoidable. The early universe, turbulent and violent though it was capable of producing wonders so massive, so ordered, and so improbable that they challenge everything we thought we knew, forcing us to confront not only the mechanisms of creation but the very limits of human understanding. The galaxy's enormity cannot be understood without confronting the invisible forces that govern cosmic architecture. Gravity, dark matter, and the interplay of energy and mass are the unseen sculptors shaping the universe, creating order amid apparent chaos. These forces operate on scales that dwarf human experience, bending space and time, orchestrating the movements of stars, and gathering matter into structures whose size and complexity are almost impossible to imagine. This galaxy, massive and ancient, is a testament not only to the material universe we can observe but also to the hidden dynamics that give it shape, mass, and coherence. Cinematic imagery illuminates these hidden processes. Picture vast, invisible webs stretching across space, their strands composed of dark matter, carrying gas and stars along gravitational currents. These cosmic filaments are the scaffolding upon which galaxies form, invisible to the eye yet detectable through their effects on luminous matter. The galaxy emerges from this scaffold like a giant cradled in unseen hands, its mass anchored and guided by forces that remain largely mysterious. Observers peer through powerful instruments, tracing the faint distortions of light, the subtle curvatures of space-time, and the intricate dance of matter, all evidence of forces shaping the colossal entity before them. Gravity is the most familiar yet profound of these forces. It acts across billions of light-years, pulling matter together into filaments, knots, and eventually galaxies. In this early universe, gravitational interactions were more violent, rapid, and influential than they are today. Proto-galaxies collided, gas clouds compressed, and star formation accelerated in ways that challenge conventional timelines. The galaxy in question seems to have taken full advantage of these primordial dynamics, assembling mass at a rate that existing models struggle to replicate. Its stars formed in bursts, its gas concentrated efficiently, and its structure stabilized far sooner than theory predicts, suggesting an intricate interplay between visible matter and the unseen gravitational framework. Dark matter, while invisible, exerts a critical influence. It provides the gravitational scaffolding necessary for galaxies to form, dictating where matter can accumulate and how structures evolve. In simulations, dark matter halos act as gravitational anchors, pulling gas into dense regions and enabling star formation. The galaxy's early, massive assembly hints at the possibility of unusually concentrated dark matter in its region of space. Perhaps this halo was denser, more effective, or somehow more efficient at gathering matter than typical early universe halos. The presence of such hidden mass could explain the rapid formation, yet it also opens new questions. What conditions allowed this halo to grow so quickly, and how common might such early, massive structures be? Energy, too, plays a critical role. Supernovae, stellar winds, and radiation pressure influence the rate at which gas collapses to form stars. In ordinary galaxies, these processes create feedback loops, regulating growth and preventing unchecked accumulation. Yet in this galaxy, the feedback mechanisms seem to have been balanced in an almost perfect way, efficient enough to fuel rapid growth, yet restrained enough to avoid dispersing material. This delicate equilibrium hints at hidden efficiencies or even previously unknown processes operating in the early universe, mechanisms that allowed a massive structure to emerge from chaos without being torn apart. The emotional impact of understanding these hidden forces is profound. There is awe in recognizing that the universe operates according to rules both elegant and subtle, capable of producing colossal entities in ways that stretch comprehension. There is also humility as we realize how limited our perception is. We see only the luminous matter, the photons that reach our instruments, while the underlying forces, dark matter, gravity, energy flows, remain largely inferred, hidden, and enigmatic. The galaxy becomes a reminder that reality is deeper, richer, and more complex than immediate observation reveals. Contrast frames this understanding dramatically. Visible light shows the galaxy as immense, luminous, and ordered. Invisible forces reveal the mechanisms that shaped it, stretching across scales and influencing structures far beyond human sight. This interplay between seen and unseen, known and hypothesized, creates both intellectual fascination and narrative tension. The audience is invited to imagine the hidden scaffolding of the cosmos, the silent forces orchestrating the growth of giants, while simultaneously marveling at the luminous beauty they produce. Cinematic description emphasizes the grandeur of these forces. Picture invisible threads of dark matter bending space, creating ripples in the cosmic web. Gas clouds collapse along these threads, igniting clusters of stars whose light eventually reaches Earth. Supernova explosions punctuate the darkness, scattering elements necessary for future generations of stars. Gravity acts silently yet irresistibly, shaping the flow of mass over billions of years. Every frame conveys the sense that the galaxy is both a product of its environment and a force in its own right, interacting dynamically with the cosmos even as it forms. Philosophically, this section invites reflection on the nature of causality and influence. Humans tend to perceive the world in terms of direct action and visible effects, but the cosmos operates on scales and through mechanisms that often elude direct observation. The galaxy's formation demonstrates that the largest structures in the universe are the product of both visible matter and invisible forces, a reminder that understanding requires inference, imagination, and a willingness to confront uncertainty. It challenges anthropocentric notions of immediacy, causality, and comprehension, highlighting the depth and subtlety of natural processes that govern existence. The narrative function of this section is to deepen the audience's appreciation of the galaxy's context. Previous sections established the anomaly, its size, and its early formation. Here, the focus shifts to explanation, without revealing a full solution. The hidden forces behind the galaxy provide both insight and continued mystery, emphasizing that even as we observe, much remains concealed. This tension sustains engagement, balancing scientific explanation with the wonder and suspense that drive cinematic storytelling. The galaxy's mass, age, and structure are thus inseparable from the unseen dynamics shaping it. Each photon received is evidence of the interplay between light and shadow, matter and force, chaos and order. The audience is invited to imagine the cosmic web, the invisible architecture stretching across billions of light-years, within which this galaxy emerged as a giant. The scale, complexity, and subtlety of these processes underscore both the ingenuity required to study them and the vastness of the universe in which they operate. By the end of this section, the audience grasps that the galaxy is not merely an object but a nexus of interactions, a manifestation of hidden forces operating on incomprehensible scales. Its existence is a testament to gravity's relentless pull, dark matter's silent scaffolding, and the delicate balances of energy that allow matter to accumulate into structures both massive and elegant. And as the narrative drifts back from instruments, simulations, and visualizations to the silent cosmos, one truth becomes clear. The universe's giants are not born by chance alone. They are sculpted by invisible hands, forces that shape reality on a scale that dwarfs human comprehension and invites endless wonder. Every photon streaming from this colossal galaxy is more than light. It is a messenger, carrying within it the encoded secrets of creation, evolution, and the raw forces that govern the cosmos. Starlight, in its journey across billions of years, has witnessed the universe in its infancy, passing through vast expanses of emptiness, weaving between cosmic structures, and bending under the influence of gravity. Each particle of light, faint yet persistent, is a time capsule, preserving the history of this massive galaxy and the turbulent epoch in which it was born. To study this starlight is to undertake an archaeological expedition across space and time, uncovering layers of information that reveal both the galaxy's nature and the universe's hidden truths. Cinematic imagery enhances this perception. Envision photons leaving the galaxy's core, racing outward across the void, stretching and reddening as they traverse the expanding universe. They pass ghost-like through interstellar dust, deflected subtly by dark matter, delayed in their journey by gravitational wells. After billions of years, they finally arrive at Earth, captured by telescopes with instruments sensitive enough to detect whispers of energy that would otherwise be lost in the cosmic background. These photons are faint echoes of stellar nurseries, supernovae explosions, and gravitational interactions, each one telling a story encoded in color, intensity, and wavelength. Spectroscopy allows astronomers to decode these messages. By splitting light into its component wavelengths, scientists can detect the fingerprints of chemical elements, revealing the composition of stars, gas, and dust within the galaxy. Elements heavier than helium, carbon, oxygen, iron, suggest that multiple generations of stars have already lived and died, enriching the interstellar medium. Such observations are startling given the galaxy's youth. In less than 1 billion years, it has already produced stars, recycled material, and built a chemical complexity unexpected for its epoch. Each spectral line is a clue, each absorption and emission feature a testament to processes occurring under conditions far beyond ordinary imagination. The starlight also carries information about motion and mass. Doppler shifts reveal velocities of stars orbiting the galactic center, gas streams flowing through spiral arms, and the dynamics of regions still forming new stars. Gravitational lensing produces distortions in the light of background galaxies, offering indirect yet precise measurements of the galaxy's total mass, including its invisible dark matter halo. By analyzing these subtle effects, astronomers gain insight into the invisible scaffolding that supports the galaxy, mapping the unseen forces that have allowed it to grow so quickly and maintain structural stability despite its young age. Emotionally, the study of starlight is a blend of awe and humility. Each photon is a survivor of billions of years, a witness to a universe that existed long before human history. Observing it creates a profound connection to cosmic time, a bridge between the observer and a distant epoch in which the rules of formation were still being written. There is wonder in realizing that light itself can be a repository of knowledge, capable of revealing secrets hidden across unimaginable distances. There is also a subtle fear, a recognition that even with our most advanced instruments, we perceive only a fraction of reality. The universe communicates in ways that challenge the limits of perception, forcing us to infer, imagine, and hypothesize. Contrast amplifies the narrative. The galaxy appears orderly and massive, its structure smooth and almost serene, while the starlight reveals a tumultuous history of star formation, chemical enrichment, and gravitational struggle. The visible calm masks underlying chaos, a reminder that appearances can be deceiving, and that understanding requires careful analysis, patience, and imagination. This juxtaposition deepens the audience's engagement, emphasizing both the beauty and the complexity of the galaxy, and the intricate dance of processes that gave rise to it. Cinematic description underscores the drama of discovery. Imagine telescopes perched on mountaintops, instruments glowing softly in darkened rooms, researchers poring over graphs of spectral lines that curve and spike with meaning. Data streams across monitors like a flowing river, each readout a fragment of the galaxy's biography. Infrared images reveal hidden star-forming regions, optical observations illuminate spiral arms, and radio maps trace molecular clouds rich in the elements of creation. The galaxy comes alive not merely as an object in space but as a narrative, a story told in the language of light and interpreted through human ingenuity. Philosophically, starlight invites reflection on the nature of observation and knowledge. The universe communicates continuously, yet much of its message is subtle, indirect, or encoded in forms that require extraordinary effort to decipher. Light carries both information and mystery, revealing patterns while leaving gaps, offering insight while demanding interpretation. In studying this galaxy, humans engage in an act of translation, converting photons into knowledge, converting faint signals into understanding. It is a reminder that knowledge is always mediated, partial, and provisional, dependent on both observation and interpretation. The galaxy's starlight also challenges assumptions about early cosmic evolution. Its chemical composition, star formation rate, and structural maturity indicate processes occurring more efficiently and rapidly than previously thought possible. These observations force scientists to revisit models of matter accumulation, stellar evolution, and galactic dynamics. If such a massive galaxy could exist so early, then the universe may be more inventive, more capable of rapid organization, and more complex than our simulations allow. Every photon is a subtle rebellion against expectation, a reminder that the cosmos is not constrained by human assumptions. Narratively, this section functions as a bridge between discovery and explanation. Previous sections focused on the galaxy's size, mass, and context in the young universe. Here, starlight becomes the medium through which those properties are revealed, offering tangible evidence while preserving mystery. The audience experiences both the thrill of observation and the intellectual challenge of interpretation, gaining insight into how astronomers reconstruct the history of a distant and enigmatic object. The galaxy is no longer a distant point of light, it is a dynamic, evolving system, its biography encoded in every photon that reaches Earth. Tension builds as each new observation suggests both answers and additional questions. Spectral data reveal maturity, yet also hint at rapid, almost violent star formation. Gravitational lensing confirms extraordinary mass, yet implies complex interactions with dark matter. Infrared observations uncover hidden regions, yet raise questions about energy balance, gas dynamics, and structural stability. Each discovery clarifies one aspect of the galaxy while deepening the mystery of its formation, creating a narrative rhythm of revelation and suspense that maintains audience engagement. By the end of this section, the audience is fully immersed in the idea that starlight is more than illumination. It is a narrative medium, a cosmic ledger recording the history of galaxies, stars, and the universe itself. The photons arriving from this galaxy are messengers from a distant epoch, carrying information about mass, motion, chemistry, and structure. They allow humans to connect with a time and place beyond direct experience, translating the language of the cosmos into knowledge, speculation, and wonder. And as the gaze lifts from monitors to the night sky, across telescopes and mountain ridges, one truth crystallizes: every glimmer of starlight is a story, every spectral line a secret, and this massive galaxy, through the photons it has sent across billions of years, speaks to humanity of the universe's capacity for complexity, scale, and mystery, reminding us that even the faintest light can illuminate the deepest truths. The discovery of this colossal galaxy reverberates far beyond the confines of a single observation. It challenges our understanding of the very mechanisms of cosmic evolution. For decades, cosmologists have constructed a narrative in which the universe gradually organizes itself. Small clumps of matter coalesce into stars, stars gather into galaxies, galaxies merge to form larger structures, and over billions of years the cosmic web emerges in a predictable pattern. This galaxy, ancient and massive, does not fit neatly into that story. It appears as if the universe, in its youth, had already achieved feats of organization and scale that current models insist were impossible. Its existence forces scientists to question the assumptions underpinning the formation and growth of all early galaxies. Cinematic imagery helps convey the magnitude of these implications. Picture the cosmic web stretching across the void, delicate filaments of dark matter threading galaxies together, as if invisible strings pull the universe into a tapestry of structure. Within this network, the newly discovered galaxy emerges as a titan, dominating its local environment, bending light from distant galaxies, and influencing the motion of neighboring structures. Its presence suggests that the universe was capable of assembling complexity far faster than previously believed, a revelation that reshapes the timeline of cosmic evolution. The early universe, long thought chaotic and slow, appears capable of rapid, almost deliberate organization. The implications extend to star formation. The galaxy's light and spectral signatures indicate that its stars formed quickly and efficiently, far exceeding the rates predicted by standard models. This suggests that the conditions for star formation in the early universe may have been more favorable, or more extreme, than scientists had imagined. Perhaps gas clouds collapsed with greater ease, or dark matter provided stronger gravitational scaffolding, or feedback mechanisms were fine-tuned in ways that accelerated growth. In any case, the galaxy reveals that the universe could generate immense stellar populations in remarkably short timescales, fundamentally altering our understanding of how galaxies evolve. This discovery also challenges assumptions about mass accumulation. Traditional models posit a slow hierarchical process. Small galaxies merge, accrete gas, and gradually build mass. Yet here is a galaxy that has already achieved an enormous mass in a universe less than 1 billion years old. Its gravitational influence on surrounding matter suggests that massive galaxies may form earlier than previously believed, potentially dominating their neighborhoods and influencing the formation of smaller galaxies. The hierarchical model is not invalidated entirely, but it must now accommodate the possibility of extraordinary early growth, suggesting that the early universe was a more dynamic and unpredictable place than current theories predict. Emotionally, the implications are profound. For scientists, there is exhilaration in confronting evidence that expands the boundaries of understanding, but also a subtle unease. To see models challenged so fundamentally is to recognize the provisional nature of knowledge. What we take for granted as truth may be overturned by a single observation. The galaxy, through its existence and properties, embodies both wonder and intellectual discomfort. It is a reminder that the universe is not obligated to follow human expectations, and that the process of discovery is as much about confronting surprises as confirming predictions. Contrast heightens the impact. The early universe has long been envisioned as a turbulent, chaotic landscape, clumps of gas forming irregular galaxies, collisions shaping structures slowly over time. Against this backdrop, the galaxy appears serene, massive, and fully formed, a visual and conceptual shock. This juxtaposition emphasizes the extraordinary nature of the observation, making the audience aware not only of the galaxy's scale but also of the profound challenge it poses to the story of cosmic evolution. It is both anomaly and archetype, a singular object that reshapes the narrative of the young universe. The discovery also has implications for the study of dark matter and energy. The galaxy's rapid assembly and enormous mass suggest that unseen forces may have played a role in accelerating its growth. Dense dark matter halos could have guided matter efficiently into the forming galaxy, while the expansion of space itself may have influenced the distribution of mass in unexpected ways. These hidden dynamics raise questions about the universality of existing cosmological models and hint at processes that may operate differently in the early universe compared to later epochs. Each observation challenges researchers to refine simulations, adjust assumptions, and explore possibilities beyond conventional frameworks. Philosophically, the galaxy forces a confrontation with the scale and pace of the cosmos. Human intuition is ill-suited to comprehend processes that occur over billions of years, across vast distances, and under conditions unlike anything on Earth. Yet through careful observation and theoretical modeling, we glimpse a universe capable of astonishing efficiency and rapid organization. The galaxy embodies this tension between human perception and cosmic reality, demonstrating that evolution on the grandest scales is governed by rules that may defy expectation, yet are detectable and interpretable through persistent effort. Cinematic visualization reinforces these concepts. Imagine a time-lapse sequence stretching across billions of years. Matter flows along dark matter filaments, gas clouds collide and ignite, stars form in dense clusters, and the galaxy grows, its spiral arms unfurling in a dance dictated by gravity and unseen forces. Neighboring structures respond to its gravitational pull, smaller galaxies orbit, merge, or are disrupted, while light from distant sources bends under its immense mass. Each visual frame conveys both process and scale, translating abstract cosmic evolution into imagery that engages the imagination and conveys the stakes of discovery. The narrative function of this section is critical. While earlier sections focused on discovery, scale, and formation context, here the story turns to consequences. The galaxy's existence is not merely an observation. It is a clue, a puzzle, and a catalyst for rethinking the entire timeline of cosmic history. The audience begins to understand that this is not just a story about one extraordinary galaxy, but about the potential limits of human knowledge, the flexibility of the universe, and the dynamics that shape all structure in space and time. Tension is maintained as the implications unfold. If galaxies could form massive structures so early, what other surprises remain hidden in the depths of space? Are there other giants, more massive and mature, waiting to be discovered? Could this force a rewriting of the early universe's history, redefining our models of star formation, galactic interaction, and mass distribution? Each answer seems to raise more questions, creating a narrative rhythm of curiosity, discovery, and awe. By the end of this section, the audience is confronted with the profound scope of the galaxy's significance. Its mass, age, and structure challenge the foundations of cosmic evolution, suggesting a universe more dynamic, efficient, and complex than previously thought. The galaxy becomes a symbol of both empirical observation and conceptual challenge, a reminder that the universe's story is far from complete and that each discovery has the potential to rewrite the narrative of cosmic history. And as the narrative pans out from instruments, simulations, and visualizations to the vast expanse of space, one realization crystallizes. The galaxy is not just a relic of the past. It is a key to understanding the forces, timelines, and processes that govern the evolution of all structure in the universe. Its secrets echo across billions of years, reshaping our understanding of how the cosmos grows, evolves, and astonishes those who dare to observe it. Confronting the existence of this massive galaxy forces a reckoning not only with scientific understanding but with philosophical contemplation. Its sheer size, age, and maturity challenge the human mind in ways that are both exhilarating and unsettling. To truly grasp the implications of a galaxy that formed so early in the universe, one must expand perspective beyond everyday experience, beyond terrestrial scale, beyond the limits of common intuition. The galaxy is a monument to cosmic possibility, an entity whose immensity dwarfs human comprehension and invites reflection on our place in the universe. Its weight is not only gravitational, it is existential. Imagine standing on a mountaintop at night looking up at the sky. Each point of starlight seems distant yet familiar, a comforting constant in the darkness. Now, consider that one of those points, faint though it may appear, represents a galaxy hundreds of billions of times the mass of our Sun, formed when the universe was still in its infancy. The contrast between human scale and cosmic scale is overwhelming. Time stretches and compresses simultaneously. The galaxy existed billions of years before humans, yet its light reaches us now, connecting past and present in a single delicate bridge. The mind struggles to hold these concepts, to reconcile the vastness of space with the minuteness of human experience, to integrate billions of years and unimaginable mass into an accessible narrative. Cinematic imagery captures this emotional and philosophical resonance. Picture a single photon leaving the galaxy, traveling for billions of years across the silent void, bending under gravitational influences, threading through cosmic structures, and finally striking a detector on Earth. That photon is a messenger, carrying with it the weight of a distant epoch, a time when stars ignited for the first time, when matter arranged itself into patterns that would ultimately define the structure of the universe. Its journey is both literal and metaphorical, representing the connection between the incomprehensible immensity of the cosmos and the fragile human desire to understand it. The philosophical implications extend to concepts of scale, time, and knowledge. Humans are accustomed to thinking in terms of what is observable and tangible: mountains, oceans, continents, or the passage of years and centuries. Yet the universe operates on scales that dwarf these reference points. The galaxy exists on a mass scale, a temporal scale, and a spatial scale that defy everyday comprehension. Philosophers and scientists alike are forced to grapple with questions of magnitude. How can one meaningfully perceive a system billions of times the mass of the Sun? How can the mind internalize events that occurred billions of years ago? What does it mean to exist in a universe capable of producing such structures, when individual human life is so brief in comparison? Contrast deepens this existential contemplation. While humans live in a world governed by familiar rules, predictable cycles, and daily rhythms, the universe operates according to laws that manifest on scales both terrifying and sublime. The galaxy appears calm and structured, yet its formation was a result of violent processes, chaotic energy, and rapid accumulation. The juxtaposition of serenity and turbulence, order and chaos, magnitude and minuteness, creates a tension that is both intellectual and emotional. It reminds observers that reality is multilayered, that what is visible is only a fragment of a far more complex cosmic narrative. Staring at this galaxy also provokes reflection on human ambition and knowledge. Every scientific observation, every theoretical model, is an attempt to bridge the gap between our limited perception and the vastness of the universe. Yet here is a system whose scale and age challenge even the most sophisticated understanding. It is a reminder of both human ingenuity and human limitation. We can measure, model, and theorize, yet the immensity of cosmic processes remains ultimately beyond complete comprehension. The galaxy becomes a mirror reflecting the tension between aspiration and limitation, a symbol of the vast unknown that surrounds human endeavor. Emotionally, the immensity of the galaxy elicits both awe and vertigo. Awe arises from the recognition that the universe can create such extraordinary structures, that processes of formation and organization are capable of producing something both enormous and elegant in a mere fraction of cosmic time. Vertigo arises from the inability to truly internalize the scale: billions of solar masses, billions of years, billions of light years across. The contrast between what is understood and what is beyond comprehension evokes a sense of humility, a reminder that the universe is not tailored to human perception, and that the mind must stretch and strain to grasp even fragments of its reality. Philosophical inquiry deepens when considering time. The galaxy's light, traveling for billions of years, brings the past into the present, compressing epochs into a single observation. The human mind is accustomed to linear, immediate experiences, yet here is a phenomenon that collapses billions of years into a moment of perception. This challenges not only scientific understanding but the very way we conceive of existence, causality, and continuity. The galaxy becomes a meditation on the fluidity of time, the persistence of matter, and the ability of the universe to maintain coherence across unimaginable spans. Cinematic visualization reinforces these philosophical themes. Imagine a camera sweeping across the Milky Way, past countless stars and planets, only to focus on a faint, distant glow, the galaxy billions of light years away. The lens captures both its majesty and its isolation, emphasizing the vast gulf of space and time that separates observer from object. As the camera zooms closer, revealing spiraling arms, glowing star clusters, and dense cores of matter, viewers are invited to feel both the exhilaration of discovery and the vertigo of perspective. Every frame conveys the tension between human understanding and cosmic immensity, translating abstract concepts into visceral experience. The narrative role of this section is crucial. While earlier sections focused on discovery, scale, and scientific implications, this section emphasizes the human response to immensity. It bridges empirical observation and philosophical reflection, allowing the audience to experience the galaxy not merely as data, but as a stimulus for awe, contemplation, and existential questioning. It reinforces the emotional and intellectual stakes of the narrative, deepening engagement by connecting cosmic phenomena to the universal human experience of wonder and curiosity. Contrast is again central. On one side, human life is fleeting, knowledge is partial, and perception is limited. On the other, the universe is vast, processes unfold over billions of years, and structures of unimaginable mass and complexity exist. This contrast magnifies both the humility and the exhilaration of comprehension. The galaxy embodies the duality of the universe, simultaneously knowable and unknowable, observable yet ultimately beyond full grasp, massive yet distant. Observers are drawn into a dialogue with the cosmos, forced to confront their place in an immense and indifferent yet astonishingly intricate universe. By the end of this section, the audience is invited to carry a dual awareness, the empirical and the philosophical, the measured and the imagined. The galaxy's mass, age, and maturity become more than scientific facts. They are lenses through which to examine the nature of perception, the limitations of understanding, and the profundity of cosmic scale. Viewers are left with a sense of wonder, a recognition of human curiosity, and an appreciation for the grandeur and mystery that define existence on the largest scales. And as the gaze lifts from simulations, graphs, and telescopic images to the night sky, one realization crystallizes. The galaxy is a reminder that the universe is not only a laboratory for scientific inquiry but also a canvas for contemplation, a vast and intricate theater of existence in which the immensity of matter, time, and space invites both comprehension and reflection, leaving humanity suspended between awe and humility, wonder and mystery. The universe is not static. It is a stage of constant motion, interaction, and transformation. Galaxies, far from existing in isolation, are engaged in a ceaseless dance, moving along invisible gravitational pathways, colliding, merging, and shaping one another across billions of years. The massive galaxy at the center of our exploration is no exception. Its formation, growth, and structure are intimately tied to the dynamics of cosmic collisions and interactions, processes that are both violent and spectacular, capable of creating unimaginable complexity from chaos. Understanding this dance provides a window into how the cosmos evolves, revealing patterns and forces that govern the assembly of structures on a grand scale. Cinematic imagery brings this drama to life. Picture vast streams of stars and gas twisting and spiraling through space, gravitational tugs pulling galaxies toward one another in slow-motion collisions that unfold over millions of years. Clouds of hydrogen ignite in brilliant bursts as they compress under gravitational stress, forming clusters of newborn stars. Dark matter halos interact silently, guiding the trajectories of luminous matter, their invisible influence shaping outcomes that would otherwise seem chaotic. In the background, cosmic radiation and supernovae explosions illuminate the scene, punctuating the darkness with energetic flashes, as if signaling the universe's own heartbeat. The colossal galaxy's rapid growth suggests that it may have undergone, or been influenced by, early mergers with smaller galaxies. Such collisions are not destructive in the long term. Rather, they are formative, concentrating matter, triggering bursts of star formation, and building mass more efficiently than isolated growth could achieve. Simulations of galactic evolution show that these cosmic encounters can dramatically accelerate the accumulation of stars and gas, allowing galaxies to achieve extraordinary mass in remarkably short timescales. In the case of this galaxy, the combination of early formation, rapid growth, and structural maturity points to the possibility of repeated, high-efficiency interactions that shaped its current form. These collisions also leave distinct signatures in the galaxy's structure and motion. Stellar populations may display varying ages and chemical compositions, evidence of multiple star-forming events triggered by mergers. Gas streams may flow in complex, non-uniform patterns, reflecting the gravitational influence of past interactions. The galaxy's dark matter halo, inferred from gravitational lensing and orbital velocities, may be more massive or asymmetrical than expected, hinting at the unseen scaffolding that guided these cosmic dances. Each piece of evidence, subtle though it may be, helps astronomers reconstruct the choreography of collisions that allowed such a massive structure to emerge so early in cosmic history. Emotionally, this section evokes a sense of cosmic awe and dynamism. Collisions on these scales are almost unimaginable, involving trillions of stars and vast clouds of gas moving with precision dictated by gravity yet governed by chaos. The viewer is drawn into a narrative of both violence and creativity, recognizing that destruction and creation are intertwined at the largest scales. Stars may be ripped from one galaxy and assimilated into another, gas may ignite in brilliant new generations of stellar activity, and the resulting galaxy may emerge more massive, more luminous, and more complex than any of its progenitors. This duality, destruction fueling creation, underscores the power and subtlety of cosmic processes. Contrast heightens narrative tension. On one hand, collisions are chaotic, violent, and unpredictable. On the other, they produce order, structure, and massive systems capable of surviving for billions of years. This juxtaposition mirrors the larger story of the universe, where forces both violent and subtle sculpt existence, and where seemingly destructive events become essential components of long-term organization. The galaxy embodies this principle. Its immensity and maturity are the direct result of interactions that might have appeared catastrophic in isolation, yet collectively created a system of extraordinary scale and stability. Cinematic visualization emphasizes the grandeur of this galactic dance. Imagine the galaxy approaching a smaller companion, gravitationally tugging streams of gas and stars, spiraling around one another in a slow, elegant orbit. As the galaxies merge, tidal forces stretch their edges, creating luminous bridges and arcs of material that glow against the cosmic void. Star formation is ignited in bursts, lighting up previously dark regions with clusters of new suns. Meanwhile, dark matter halos intersect and intertwine, shaping the gravitational landscape silently yet profoundly. Every frame conveys motion, energy, and consequence, translating abstract physical processes into a visual spectacle that communicates both scale and intensity. The scientific significance of galactic collisions extends beyond individual galaxies. These interactions influence the distribution of matter across the universe, the formation of clusters, and the evolution of large-scale structure. Collisions trigger the recycling of material, spreading elements forged in stars into interstellar and intergalactic space, thereby seeding future generations of stars and planets. In the case of this galaxy, early collisions may have concentrated matter efficiently, creating conditions for rapid star formation and chemical enrichment, and contributing to its massive size and structural coherence. Each collision is both a process of growth and a mechanism of cosmic storytelling, leaving traces that scientists can decipher billions of years later. Philosophically, the dance of galaxies offers a meditation on cause and effect, chaos and order. In human experience, destruction and creation are often separated by time or context. In the cosmos, they coexist, intertwined across vast scales. The galaxy's evolution illustrates this principle, showing that interactions that appear violent or chaotic can produce lasting beauty and structure. It also suggests that the universe operates according to patterns and rules that are observable yet often counterintuitive, challenging human preconceptions and inviting reflection on the nature of progress, transformation, and emergence. The narrative role of this section is pivotal. Previous sections established the galaxy's mass, formation, and implications for cosmic evolution. Here, the story zooms into the processes that physically shaped the galaxy, the interactions, collisions, and gravitational choreography that created its present form. This adds depth to the audience's understanding, bridging the gap between observation and explanation, and maintaining engagement by presenting both dynamic action and scientific insight. The galaxy becomes more than an object of study. It is a participant in an ongoing cosmic narrative, a character in the universe's story of motion and transformation. Contrast continues to enrich engagement. While the galaxy appears static in images captured from Earth, its history is one of continuous motion, energy, and interaction. The juxtaposition between the frozen image and the dynamic processes behind it reinforces a central theme of cinematic science storytelling, that the universe is alive with movement and drama, even when perceived from our distant vantage point. This duality engages both curiosity and imagination, making the galaxy a compelling symbol of cosmic dynamism. By the end of this section, the audience appreciates that the galaxy's size and maturity are not solely the result of isolated growth but are inseparable from its interactions, mergers, and collisions. The cosmic dance has sculpted, accelerated, and enriched the system, leaving behind a complex tapestry of stars, gas, and dark matter that is observable today. The galaxy is both the outcome of these interactions and a testament to the power of gravity, motion, and time, a monument to the ongoing choreography that defines the evolution of the cosmos. And as the narrative pans back from simulations, telescopic observations, and visualizations of spiraling stars to the vastness of intergalactic space, one truth becomes clear: galaxies do not grow in isolation. They are participants in an intricate dance, a symphony of collisions and mergers that shape the universe, and this massive galaxy, with all its complexity and immensity, is a vivid embodiment of the profound creativity and violence that underpin cosmic evolution. Beneath the luminous stars and swirling gas of the massive galaxy lies a deeper, hidden truth. The galaxy's true form, stability, and growth are dictated not just by the matter we can see, but by the invisible architecture of dark matter. This mysterious substance, undetectable by conventional instruments yet making up the majority of the universe's mass, acts as a silent orchestrator, shaping the evolution of galaxies, guiding the assembly of cosmic structures, and influencing the very flow of space itself. Without understanding dark matter, no account of this galaxy's formation or enormity would be complete, for it is the invisible hand that allowed such a colossal system to emerge in the youth of the universe. Cinematic imagery brings the concept to life. Envision vast, unseen webs stretching across the cosmos, their strands woven from a substance we cannot directly observe. These filaments thread galaxies together, creating a scaffolding that organizes matter over billions of light-years. Stars, gas, and visible galactic structures flow along these invisible pathways, drawn by gravitational forces that only manifest in their effects. In this framework, the massive galaxy emerges not as a solitary entity but as a nexus, shaped and supported by the hidden currents of dark matter that silently dictate where mass can gather, which structures can stabilize, and how efficiently star formation can proceed. The role of dark matter is both structural and dynamic. Its gravitational pull attracts ordinary matter, accelerating the collapse of gas clouds into dense star-forming regions. It governs the rotation curves of galaxies, explaining why stars on the outskirts move faster than visible mass alone would allow. It guides the merger of smaller proto-galaxies, influencing trajectories and ensuring that interactions lead to coherent structures rather than chaotic dispersal. In the case of this massive galaxy, its rapid formation and early maturity may be the result of an unusually dense or efficiently distributed dark matter halo, providing the gravitational foundation necessary for assembling billions of solar masses in a relatively brief cosmic period. Spectroscopic and gravitational lensing observations provide indirect evidence of this invisible framework. Variations in light from background galaxies, subtle distortions in stellar motions, and the velocity profiles of orbiting gas all hint at a vast underlying mass that cannot be seen. These clues allow astronomers to map the distribution of dark matter, revealing a complex and intricate structure that supports the visible galaxy. The image of a galaxy, then, is incomplete without acknowledging the hidden forces that anchor it, the silent scaffolding that turns chaos into coherence and allows extraordinary structures to form. Emotionally, the concept of dark matter evokes a combination of awe and unease. Awe arises from the realization that the universe operates with layers beyond perception, that entire cosmic edifices are shaped by forces we cannot directly observe. Unease comes from the humility it imposes. Even with our most advanced telescopes and simulations, we are only seeing the tip of a vast iceberg, unaware of the majority of mass and influence that shapes reality. The galaxy embodies this duality, its grandeur a product of both visible matter and invisible architects, reminding observers of the limits of human perception while simultaneously expanding the imagination. Contrast enhances the narrative tension. The luminous stars, glowing nebulae, and sweeping spiral arms are tangible and measurable, familiar in their physics and observable beauty. In contrast, dark matter is intangible, inferred, and mysterious, yet its influence is undeniable. This interplay between the seen and unseen mirrors a central theme of cosmic storytelling, that the universe operates on multiple layers simultaneously, with visible phenomena often dependent upon invisible, subtle forces that define structure, evolution, and destiny. The galaxy exists in a delicate balance, its visible form a reflection of an unseen architecture whose influence stretches far beyond the reach of observation. Cinematic visualization underscores this hidden drama. Imagine an invisible web pulsing across space, strands converging and diverging as galaxies form along its nodes. Gas clouds fall into gravitational wells, igniting stars in bursts of incandescent light. Protogalaxies merge along the filamentary network, their interactions guided by the silent hands of dark matter halos. Supernovae punctuate the dark expanse with energy, yet the underlying structure remains stable, invisible yet decisive. Every frame conveys the tension between visibility and invisibility, chaos and order, emphasizing that the universe's grandest structures are the product of forces beyond direct perception. The philosophical implications of dark matter are profound. It challenges the assumption that what is visible constitutes the totality of reality. The galaxy, massive and luminous though it appears, owes much of its existence to an unseen force, reminding observers that reality is multi-layered, complex, and often counterintuitive. The human tendency to trust the observable can mislead. Comprehension requires inference, modeling, and imagination. In this sense, the study of dark matter is as much a philosophical endeavor as a scientific one, expanding awareness of how little we perceive and how much lies beneath the surface. The narrative function of this section is to deepen understanding of causality and structure. Earlier sections explored the galaxy's mass, formation, and interactions. Here, the focus shifts to the foundational forces that made those phenomena possible. The audience is invited to consider not only what the galaxy is, but how it could exist at all, tracing its evolution to the silent, invisible currents of dark matter that shaped its destiny. This adds intellectual depth, sustaining engagement by revealing layers of complexity that operate beyond the immediately observable universe. Contrast continues to heighten engagement. The galaxy's luminous features, spectacular and tangible, draw the eye and inspire wonder. Beneath that splendor lies an invisible framework, equally vast, equally powerful, yet entirely hidden from direct view. This duality amplifies the sense of mystery, emphasizing that the universe is not simply a collection of observable objects but a network of forces, interactions, and influences that extend beyond comprehension. The massive galaxy becomes both a triumph of visibility and a testament to invisibility, a reminder that even the most extraordinary structures are contingent upon hidden dynamics. The study of dark matter also has implications for cosmology at large. If early galaxies like this one required dense dark matter halos to form so rapidly, then the distribution, behavior, and properties of dark matter throughout the universe may be more complex than previously understood. This could influence models of galaxy clustering, star formation efficiency, and large-scale structure evolution. Each observation of massive early galaxies provides additional constraints, refining simulations and forcing theoretical models to account for phenomena that operate on both visible and invisible scales. By the end of this section, the audience recognizes that the massive galaxy is not only a spectacle of stars and gas but a monument to unseen architecture. Its existence is inseparable from the hidden scaffolding of dark matter, whose gravitational influence shaped its formation, dictated its structure, and enabled its rapid growth. The universe, it becomes clear, is a layered reality, where what we see is only part of a deeper, more complex, and more mysterious whole. And as the narrative pans outward from telescopes, simulations, and cosmic reconstructions to the broader expanse of space, one realization crystallizes. The galaxy's grandeur is inseparable from the invisible hands of dark matter. These hidden architects, silent yet omnipresent, are the true sculptors of the cosmos, demonstrating that in the universe, what is unseen often carries as much power, influence, and significance as what is visible, shaping the destinies of galaxies, stars, and the cosmos itself. The existence of this massive galaxy presents one of the most profound mysteries of modern astronomy. How could such a colossal structure form so early in the universe's history? Conventional models of cosmic evolution suggest that galaxies gradually accumulate mass, growing through mergers and star formation over billions of years. Yet this galaxy defies those expectations, appearing fully formed, chemically enriched, and enormous in mass when the universe itself was still in its infancy. Its early emergence forces scientists to reconsider the processes that govern the young cosmos, challenging the timelines, mechanisms, and assumptions that underpin our understanding of galactic formation. Cinematic imagery brings this mystery to life. Imagine a universe filled with proto-galaxies, scattered clouds of gas, and faint, nascent stars, a chaotic landscape slowly organizing under gravity's influence. Amid this primordial turbulence, one region achieves something extraordinary. Matter accumulates at an unprecedented rate, stars ignite in rapid succession, and a massive, structured galaxy emerges seemingly ahead of schedule. Its size and maturity suggest a process more efficient than any predicted by current models, as if the universe itself accelerated the assembly of matter in this particular locale. This visual contrasts the chaotic backdrop of early space with the extraordinary coherence and scale of the galaxy, emphasizing its anomalous nature. The mystery deepens when considering star formation and chemical enrichment. Observations indicate that the galaxy contains a surprisingly high fraction of heavy elements, produced by multiple generations of stars. In a universe less than 1 billion years old, such enrichment is remarkable. It implies that star formation proceeded at extreme rates, producing and recycling elements far faster than previously thought possible. This challenges our understanding of the timescales required for nuclear processes in stars, supernova explosions, and the distribution of enriched material throughout the interstellar medium. The galaxy's very existence suggests that the early universe was capable of producing massive, complex structures in ways that stretched the limits of known physics. Dark matter plays a crucial role in unraveling this mystery. Its presence provides the gravitational scaffolding necessary for rapid mass accumulation, guiding gas and stars into dense regions that ignite star formation efficiently. Yet even accounting for dark matter, the galaxy's properties remain extraordinary. Simulations struggle to replicate such early giants, requiring extreme assumptions about halo density, efficiency of gas accretion, or early cosmic conditions. Each piece of evidence raises new questions. Was the galaxy's environment unusually favorable? Did early cosmic fluctuations concentrate matter in ways we have yet to understand? Could there be unknown processes accelerating growth in the young universe? These uncertainties frame the galaxy as both a puzzle and a beacon, highlighting gaps in our understanding and pointing toward new avenues of inquiry. Emotionally, the mystery evokes a sense of wonder and intellectual tension. There is awe in contemplating a system so massive, so old, and so efficiently formed, yet there is also unease in recognizing that our models cannot fully explain it. The galaxy becomes a symbol of both the universe's creativity and the limitations of human comprehension. It challenges scientists and observers alike to question assumptions, consider alternative possibilities, and embrace the unknown. This tension between explanation and mystery drives curiosity, sustaining engagement as the audience is drawn into the process of discovery alongside astronomers. Contrast heightens the narrative impact. On one side, existing models depict the early universe as gradually organizing, a slow and incremental process. On the other, this galaxy is already a titan, mature and structured. The discrepancy between expectation and observation creates a dramatic tension, a sense that the universe has achieved feats beyond prediction. This juxtaposition emphasizes the anomaly's significance, positioning the galaxy as a key to understanding not only individual formation processes but the broader behavior of matter in the primordial cosmos. Cinematic visualization underscores the drama of early galaxy formation. Picture streams of gas converging along dark matter filaments, colliding with proto-galaxies, igniting bursts of star formation, and assembling mass at breakneck speed. Stellar nurseries flare with intense light, while supernova explosions enrich the surrounding medium with heavy elements. The galaxy's central regions densify, forming a luminous core, while spiral arms or extended structures begin to emerge, creating a coherent and massive system against the chaotic early universe. Every frame conveys energy, urgency, and scale, emphasizing the contrast between the galaxy's rapid formation and the surrounding cosmic turbulence. The philosophical significance of this mystery is profound. The galaxy challenges assumptions about predictability, order, and causality in the cosmos. If such massive structures could emerge so early, it suggests that the universe possesses a capacity for efficiency and complexity that surpasses human expectation. This prompts reflection on the nature of scientific models. They are tools for understanding, yet they are provisional, vulnerable to revision as new observations reveal phenomena that lie beyond current frameworks. The galaxy becomes a reminder that reality may always exceed prediction, and that the pursuit of knowledge is as much about encountering surprises as confirming expectations. The narrative function of this section is to build suspense and engagement. Previous sections detailed the galaxy's scale, formation, and hidden forces. Here, the focus shifts to the unresolved questions, the anomaly that drives scientific investigation and wonder. The audience is invited into the mystery, to consider the implications of an object that defies conventional understanding, and to participate in the intellectual thrill of cosmic detective work. By emphasizing uncertainty and complexity, this section deepens emotional and cognitive investment, keeping viewers engaged as the story unfolds. Contrast continues to sustain narrative tension. The galaxy's observable features, its light, structure, and mass, are concrete, measurable, and awe-inspiring, yet they point to processes that remain elusive. Scientists can infer mechanisms, model interactions, and propose explanations, but the full story remains out of reach, hidden in the interplay of matter, energy, and time billions of years ago. This duality, what is known versus what is unknown, drives curiosity and engagement, positioning the galaxy as both an object of study and a symbol of cosmic mystery. By the end of this section, the audience appreciates that the galaxy is not simply a massive object but a profound enigma. Its rapid formation, structural maturity, and chemical complexity challenge models of early cosmic evolution, forcing reconsideration of timescales, mechanisms, and processes. It embodies the tension between observation and theory, between evidence and expectation, and becomes a focal point for contemplating the universe's capacity for rapid organization and creativity. And as the narrative pans outward from telescopes, simulations, and theoretical reconstructions to the vast expanse of space, one realization crystallizes. This massive galaxy is a cosmic puzzle, a reminder that the universe is capable of producing early giants that defy conventional understanding, and that each observation opens doors to deeper mysteries, inviting humanity to explore, question, and marvel at the extraordinary processes that govern existence on the grandest scales. No galaxy exists in isolation. Each is part of a vast, interconnected network known as the cosmic web. This massive galaxy, despite its exceptional size and early formation, is woven into an intricate lattice of filaments, nodes, and voids stretching across billions of light-years. Dark matter forms the backbone of this web, guiding the flow of gas and galaxies along invisible pathways, while gravity orchestrates the convergence of structures at the nodes, creating clusters and superclusters. Understanding this galaxy requires understanding the cosmic context in which it exists, the web of matter and energy that not only shapes individual galaxies but defines the architecture of the entire universe. Cinematic imagery brings the cosmic web to life. Envision a three-dimensional lattice of filaments stretching across the void, luminous galaxies strung along dark threads, and vast empty spaces punctuating the network like negative space in a grand celestial painting. Along these filaments, matter flows inexorably toward nodes where gravity concentrates mass, igniting bursts of star formation and triggering mergers. The massive galaxy stands at one of these intersections, a titanic accumulation of matter that dominates its local environment, influencing the motions of neighboring galaxies and shaping the surrounding intergalactic medium. Its position within the web is both strategic and telling, revealing how cosmic forces organize the universe on scales incomprehensible to human intuition. The galaxy's interactions with the cosmic web affect its growth, structure, and evolution. Gas funneled along filaments feeds star formation, replenishing the galaxy's reservoirs and sustaining rapid accumulation of mass. Smaller galaxies flowing along the same pathways may merge or be disrupted, adding to the galaxy's mass and complexity. The dark matter halo surrounding the galaxy interacts with the web, guiding trajectories and ensuring stability amidst gravitational perturbations. Each filament, each flow of matter, is a pathway of influence, connecting the galaxy to the broader cosmic landscape and illustrating the interdependence of structures across space and time. Emotionally, the concept of the cosmic web evokes a sense of scale, connectivity, and wonder. The galaxy is not merely a solitary giant. It is part of a network whose architecture is elegant, immense, and intricate. Observers are confronted with a universe where individual objects are embedded within a dynamic, multidimensional structure, where the formation of one galaxy is inseparable from the flow of matter and energy across billions of light-years. The idea of connectivity at such immense scales challenges human intuition, inspiring both awe and a deep appreciation for the complexity of cosmic organization. Contrast enhances the narrative. From a distance, the galaxy may appear isolated, a luminous island in darkness. Yet within the cosmic web, it is part of a vast system of interlinked structures, connected by invisible filaments and influenced by forces that extend far beyond the visible. This juxtaposition between apparent solitude and underlying connectivity reinforces the theme of hidden dynamics, showing that the universe is governed as much by unseen architecture as by visible phenomena. The galaxy's prominence is magnified when understood as both an individual entity and a node within the immense cosmic network. Philosophically, the galaxy's place in the web invites reflection on interdependence and scale. Just as human societies are shaped by networks of interaction and influence, so too are galaxies guided by gravitational, material, and energetic connections that extend far beyond their visible boundaries. The massive galaxy demonstrates that no structure in the universe is truly independent. Each is a product of both local conditions and the larger cosmic environment. Its existence is a testament to the interplay between individuality and connectivity, chaos and order, isolation and integration, across the vast expanse of space. By the end of this section, the audience understands that the galaxy is not simply a solitary marvel but a component of a grander system. Its formation, growth, and influence are inseparable from the cosmic web, a vast lattice of matter and energy that shapes the evolution of all galaxies. The galaxy's immensity is contextualized within this interconnected structure, revealing a universe in which even the largest and most extraordinary objects owe their existence to the hidden architecture of the cosmos. The discovery of this massive galaxy marks not the conclusion of inquiry, but the beginning of a deeper, more ambitious quest to understand the universe's earliest epochs. Each observation raises new questions. How did this galaxy accumulate such enormous mass so quickly? What processes enabled its rapid star formation and structural maturity? How did its environment within the cosmic web influence its evolution? And what role did dark matter and the central supermassive black hole play in orchestrating its growth? To answer these questions, astronomers are planning increasingly sophisticated observations, employing cutting-edge telescopes, advanced simulations and multi-wavelength studies to probe every aspect of its structure and history. Cinematic imagery brings the anticipation of discovery to life. Imagine telescopes scanning the night sky with unprecedented precision, instruments sensitive to infrared, X-ray and radio frequencies capturing photons that have traveled billions of years. Observatories orbiting above Earth complement ground-based facilities, peering through cosmic dust and atmospheric interference, revealing hidden regions of star formation and the faint glow of the earliest stellar generations. Supercomputers simulate the galaxy's growth, modeling interactions with dark matter, gas inflows along cosmic filaments, and the effects of energetic feedback from its central black hole. Every pixel of data, every calculation, contributes to an unfolding narrative that bridges observation and theory, gradually illuminating the processes that shape this extraordinary system. The pursuit of understanding also evokes profound emotional resonance. There is the excitement of potential discovery, the possibility of uncovering phenomena that defy current models or reveal entirely new aspects of cosmic evolution. There is the tension of uncertainty, the recognition that the galaxy challenges long-standing assumptions, forcing scientists to revise frameworks and embrace the unknown. And there is the awe-inspiring perspective of human ingenuity, that through technology, collaboration, and imagination humanity can study a galaxy so distant and ancient, decoding the story encoded in light that began its journey billions of years ago. Contrast enriches the narrative. The galaxy, immense and mature, stands as a testament to the complexity of the early universe, yet it is perceived only through indirect observation, filtered through instruments and interpreted via models. The gap between what is known and what remains mysterious heightens engagement, emphasizing both the galaxy's grandeur and the human drive to comprehend it. Each observation uncovers answers while simultaneously revealing further questions, a dynamic that mirrors the tension between certainty and mystery inherent in all scientific exploration. Philosophically, the quest for understanding embodies a broader meditation on knowledge, curiosity, and perspective. Observing this galaxy challenges assumptions about the universe, reminding us that even our most sophisticated models are provisional, dependent on the quality and scope of data available. The galaxy represents both a frontier and a mirror, reflecting the limits of human perception while inviting expansion of thought, imagination, and understanding. In studying it, humans participate in a dialogue with the cosmos, translating ancient photons into insight, and turning observation into narrative. By the end of this section, the audience recognizes that the story of the galaxy is ongoing. Each discovery opens new avenues of inquiry, and each unanswered question drives the pursuit of knowledge further. Future observations promise to refine understanding of cosmic evolution, illuminate the role of dark matter and black holes, and reveal the processes that govern the earliest formations of massive galaxies. The galaxy is both a subject of study and a catalyst for curiosity, inspiring continued exploration of the universe's most profound mysteries. And as telescopes swivel, simulations run, and instruments capture faint whispers of ancient light, one realization crystallizes: the galaxy's story is far from complete. Its photons, traveling across billions of years, are invitations to explore, question, and comprehend, reminding humanity that the quest for cosmic understanding is infinite, dynamic, and ever-expanding, as vast and compelling as the universe itself.